JMath.
Now, this is just a quick video to cover two smaller concepts. So in exams, they like to ask you, is a certain line a tangent or not? And then the other one is a certain dot in a circle or outside a circle or on a circle? Let's cover that quickly. If you look at the screen, a line is a tangent if it touches a circle exactly once. Okay, then obviously if it doesn't touch the circle, then it's nothing, then it's just a line. But if it intersects the circle twice, it's called a secant. So I think way back in grade 8, you learned all the terminology of what's a radius and a circumference and whatever. And then the one everybody always forgets is a secant is a line that goes through a circle and cuts it twice. So the method to work out the answer to these questions is actually very easy. I just need to do simultaneous equations. Firstly, I will have to take the line they give me, 2x equals 11, and I just need to sub it into the place of x, and then I see, do I get one answer, two answers, or no answers? And that would tell me if it is a tangent or not. So you can decide in this case if you want to get the circle into standard form and then sub in, or if you just want to sub in. It's really up to you. In this case, I am just going to sub in to see if I get one answer or more than one answer. And there I can see I have two answers, and therefore this line is not a tangent. It is called a secant. So just make sure you answer the question. Therefore, 2 points of intersection, and therefore the line is a secant. Question 2, given this circle, in each case determine if the given line is a tangent, a secant, or neither. Once again, I'm just going to follow the same steps. You can write the circle into standard form and then sub in, or you can just sub in straight away. I think it's going to be big sums either way you do it, but it's really your choice. For question A, I can then see they gave me y equals x minus 1. I can now just sub that into both y values and then just see in the end if I get 1, 0, or 2 answers. So I can see this trinomial is not going to solve easily, so therefore I'm going to sub it into the quadratic formula and just see if I'm going to get answers. It is now clear that under the square root, I'm going to have a minus 16. So therefore I can say non-real, and therefore the line does not touch the circle. So that's what we mean if we say there is no point of contact between the circle and the line, then the root would be negative in the quadratic formula, and therefore I can just say this is not a tangent or a secant. It's just a random line next to a circle. Question B, I would just follow exactly the same steps. The first thing I'm going to do is just get y alone in this case, and that would just be 5 minus x. And then I'm just going to sub that into the y values of the circle. So there's a 5 minus x, and there's a 5 minus x. Now I'm going to FOIL out, get a trinomial, and try to solve the trinomial. If I now FOIL this out, I see it simplifies to 2x squared minus 2. I take the 2 over and divide by 2. That gives me a positive 1. And the square root of positive 1 gives me a plus and a minus answer. So don't forget the plus minus because it's the key to this question. That means it cuts the circle twice, and that means it's a secant. So I just have to write for them, therefore, x would be equal to minus 1, or x would be equal to 1. Therefore, line is a secant. For question C, I will then do exactly the same and just answer them in the end. I need to start by getting y alone. So y is equal to minus 3x plus 7. I don't really like it if it's that way around with a minus in front. So I'm just going to say this is 7 minus 3x, and then I'm going to sub that in to the equation. So let's FOIL it out and see what we get in the end. And now if I factorize this, I can see this is just going to be a x minus 1. This would just be x minus 1 equals 0, and therefore x is equal to 1. That gives me one answer, and therefore the line is a tangent. Okay, I don't think it's very difficult, this concept. It's just very long and you need to write a lot. But if your algebra is strong and you practice this is free marks in an exam. Then you also get questions where they give you a random dot and a circle equation, and then they just ask you, is this dot inside, on the circle, or outside the circle? Now, this is extremely easy if you have a picture in front of you, then it's just obvious, but that's not how they're going to ask it. So they're just going to give you the algebra formulas and things, and then you need to work it out. So the easiest way to do this is just to get the distance of the radius. Okay, that's normally very easy to see from a circle formula. And then you do the distance formula between the dot and the center. If the distance is the same as the radius, the dot is on the circle, so that's what the middle question is about, And then obviously, if the distance is smaller, the dot is inside. And if the distance is greater, then the dot is outside the circle. Let's just do an example of this question so you can get your free marks in the exam. There is an alternate way to do this question where you also just sub in the coordinate and then you see, is it less or more than the radius? So in some ways that's quicker, but it is a little bit more confusing. So I'm not going to go that route, but I'm first going to simplify the circle into standard form so I can see what the center is for the circle. If I simplify the circle, I can see that the center is -2 and 3, and the radius is just 4. So now with all three of these questions, I'm just going to do the distance between the center and the dot they give me. And then I'm going to just see, is it less, equal, or more than 4? And that would then answer their question. So step 1, I am going to get the distance of AC in this case. So AC would then just be equal to, and I just sub it into the distance formula and simplify. The distance formula tells me that AC is the square root of -4 squared, which is the square root of 16, which is just 4. Therefore, the distance between the dot and the center is the same as the radius. So I can say A lies on the circle. Let's just do the other two quickly, and then you can see examples of each of them. If I now just sub in the coordinates of B, this would be a -1, that would be a 4, and then -1 plus 2 is just 1, squared is 1, and then 4 minus 3 is also 1, so that's also plus 1 squared, and therefore the distance of BC is √2. I know that √2 is smaller than 4, and then I can say, therefore, B lies inside the circle because it's not more than the radius. If I now do question C, so sorry, I'm not going to write CC on the left. I'm just going to say this is D for distance, and I can then say this is -3, this is -2, and then if I simplify this a bit, -3 plus 2 gives me -1. I can square that, and then -2 minus 3 gives me -5 squared, and this gives me the square root of 1 plus 25, so that is 26, and √26 is definitely more than 4, which is just √16, and therefore I can say C lies outside the circle. There we go, guys. These were just small, quick questions, but they are almost always one of them in an exam. And now you know how to do it. And then you can get these free marks in the exam.
If this video helped you, please like and subscribe.
JMath.